Hi, today I'd like to talk a little bit about right triangles as well as trigonometry related functions. Okay, so let's say I have a right triangle here. Okay, and with this angle being the right angle, okay, we shall have an angle here called theta. Okay, so now the sine of the angle is going to be the opposite side divided by the hypotenuse. Okay, the hypotenuse is essentially the side that's opposite the right angle and is also the longest side of the right triangle. Okay, so the sine is equal to O over H. Okay, so now the cosine now is going to be the side adjacent to the angle that's not the hypotenuse divided by the hypotenuse. Okay, so cosine is equal to adjacent over the hypotenuse. Okay, and the tangent is equal to the opposite divided by the adjacent. Okay, it's also important to know that let's say we have another angle here called alpha. Well, things are reversed because now the opposite side for alpha is A over the hypotenuse, which means then that the sine of this angle is the cosine of this angle. And because the adjacent side to alpha, that's not the hypotenuse, is this side here, then the cosine of alpha is also the sine of theta. Okay? And if the, in this case also, if let's say O over A is equal to the tangent of theta, well, the cotangent of alpha is the tangent of theta, and the cotangent is equal to essentially the adjacent divided by the opposite. Now this is related to graphing a circle. And why a circle? Well, if we were to graph a circle of a given radius, the formula for graphing it will be, let's say if we have an x coordinate and a y coordinate, will be x squared plus y squared is equal to r squared. Okay, assuming r is a given radius for the circle. Okay, which we call r. Okay, so how does that relate to right triangles? Well, if we were to relate the x squared to, if we're going to say x is equal to a and y is equal to b and r equal to c, so we can say now a squared plus b squared is equal to c squared, which what that tells me now is that I can always draw a right triangle here with the radius being the hypotenuse. Okay, the length of the radius being the hypotenuse. Okay, the x coordinate, okay, let's say for this point here, divided by the radius will be the cosine of the angle. Okay, with this being the angle. The y coordinate divided by the radius will give us the sine. Okay, so now let's say the radius is equal to 1. Okay, which means now y over 1 is equal to sine theta. Okay, so we can say now y is equal to sine theta. Okay, and we can also say now x divided by 1, which is the same as x, is equal to cosine theta. Okay, so now, and of course we know that y over x is equal to tangent of theta. So now let us do something else. Let us extend, I guess, for from the outside, a line tangent to the circle going vertically, and join it to an extension of the radius now. Okay, so now we have this bigger triangle here and the original triangle. So let's say this side here, we'll call it A. Okay, so what's the length of A? Well, A being divided by this, okay, is going to be the tangent of that. So we can say A over 1 is basically the same proportion as sine theta divided by cosine theta, which is basically tangent of theta. In fact, that may be very well the reason why we get the term tangent, because it's equal to the length of the line that's tangent and connects to the radius. It also means too that by the Pythagorean theorem, in this case, sine squared theta plus cosine squared theta is equal to 1. Anyway, that is all I have for now, and I'd like to thank you very much for watching.